everyone, welcome to my YouTube channel. This is Er.Roushan Singh. In this video I have taken a topic from matrices, that is inverse of the matrix. So here you can see what is inverse of the matrix. If A is any square matrix, then A inverse is defined as adjoint A upon det A. This is nothing but the definition of the inverse of the matrix. So in this video, and in the previous video we have found how to find the det of the matrix. For 3 by 3 matrix, for 2 by 2 matrix, we know how to find the det of the matrix. Now we need to find adjoint A, which is a typical task here. So see clearly, you will understand. So first of all, and here also one condition where det A should not be equal to 0, because if det A is equal to 0 means that A inverse does not exist. It is undefined. It becomes undefined because it is in denominator. Something by 0 is nothing but undefined. So we need to find first det of the matrix. So we will find det of the matrix here. So for this matrix we will find det of A. Det of A is equal to, you know already in determinant what we do, plus minus plus. So we will take 1 into ignoring this column and this row, we will find 4 4 ja 16 minus 9, that gives you 7. Then again minus 3, again this one. If you are taking this means ignoring this column and this row, we will write 4 minus 3. 4 minus 3 is nothing but 1. Then plus 3. So you have taken this means you have to ignore this column and this row. 3 minus 4 is nothing but minus 1. So that gives you 7 minus 3, that is nothing but 1, which is not equal to 0. That means inverse of the matrix exists. So now we need to find, we found det A that is equal to 1. We have to find adjoint of A. So for finding adjoint of A, what we are going to do means, we know adjoint A is equal to cofactor of A transpose. So it means we have to find cofactor of A matrix first. Cofactor of each elements we have to find, and then we have to do transpose. That will give you adjoint A. So we have a formula. See this formula: cofactor of any elements. Suppose it is A11. A11 means first row, first column. That gives you, that is equal to minus 1 into I plus j into minor of those elements. So what is minor of those elements means, suppose you are taking this element means you have to ignore this row and this column and you have to write the rest of the elements. 4 3 3 4, that will be your 4 3 and again 3 4. So that is nothing but minus 1 power. So what is I value here? I is A11 means 1 and j is also 1. So this is your, see here, this is A11, this is A12, this is A13, A21, A22, A23, A31, A32, A33. You know how to represent the matrix form. So suppose it is this element means I is equal to 1, j equal to 1. We will substitute here in this formula. This is 1 plus 1, that is nothing but even. So minus 1 power even, that gives you always plus only. So that is nothing but your 1 into 4 4 ja 16 minus 9, that is 7. Similar way we will find cofactor of all the elements for this and that. So that will be here, you can see. So we will find first one we found cofactor of A11. Now we will find cofactor of, that is nothing but A21, that is 3. So you write A12, that is minus 1 power 1 plus 2, that gives you 1 plus 2 means odd. Now if you are taking this element, you have to ignore this column and this row. So rest is what? 1 3 1 4. So this is your 1 3 1 4, that gives you. So always minus 1 power odd means it will be minus, and this is 4 minus 3 is nothing but your 1. So similar way we will find total. So This was the main concept how to find. Now we are not going to do this much of calculation. We will directly write how to find cofactor. Means we will write cofactor cofactor of A is equal to, we are going to find like, so first will be your plus, next minus, plus, minus, plus, minus, plus, minus, minus. From this formula this all came. Now suppose you are finding for this, means you have to ignore this column and this row. Rest is what? 4 3 3 4. So 4 4s are 16 minus 9, that gives you 7. So this is your 7. Next, for this element is ignoring this column, this row, so that will be 4 1 ja 4 minus 3. 4 minus 3 is nothing but your 1. Now for this one, ignoring this, 3 minus 4. 3 minus 4 is how much? Minus 1. Minus 1 and plus, that become totally minus 1 only. So this is no need here. Next, for this 1 means you will ignore this row and this column. So become 3 3 3 4. 4 3s are 12 minus 9. 12 minus 9 is how much? 3. 12 minus 9 is how much? 3. Next, for this one, so you have to ignore this column and this row. That gives 1 3 1 4. So 4 minus 3. 4 minus 3 is how much? 1. This will be your 1 only. So now for this one means ignoring this column and this row, that gives you 3 minus 3, that is how much? 0. Next one, this one, similar way. So ignoring this row and this column, that gives you 3 3s are 9. 9 minus 12, that is how much? Minus 3. 9 minus 12 is minus 3. Minus 3, and here it is plus, so it become plus minus minus only. Now for this 3, ignoring this row and this column, this row and this column, 3 minus 3, that gives you 0. No need of 0, no need of minus here. Next, for this one, ignoring this column, this row, 4 minus 3, how much? 1. 4 minus 3 is 1, so it is minus 1. Now this is nothing but cofactor. So what is adjoint A? Adjoint A is equal to cofactor of A transpose. So we will do transpose of this, that gives you nothing but adjoint A directly. So transpose means what? Rows will become column and column will become row. 7 minus 1 minus 1, that was row. 7 minus 1 minus 1, minus 3 1 0, minus 3 0, minus 1. So this is nothing but your adjoint A. So this is adjoint A. Now we can write, see the formula. What is A inverse? A inverse equal to adjoint A upon det A. So we will write A inverse is equal to adjoint A is nothing but this one, 7 minus 3 minus 3 minus 1 1 0 minus 1 0 minus 1 upon det A is how much? Your det A was here, you found det A nothing but 1. So that is nothing but your inverse of the matrix. So simple, you can apply for any inverse of the matrix for 3 by 3, 2 by 2 matrix, and you can get. So if you like my video, please do share, subscribe. Thank you. Let's see inverse of 2 by 2 matrix. It's very simple. Suppose a matrix is like A is equal to A B C D. Now we need to find the inverse of the matrix, so we can say A inverse is equal to adjoint A upon det A. It's very simple. What you have to do means, first of all you will find det of the matrix. Det of the matrix is nothing but AD minus BC. So you will write AD minus BC, which is not equal to 0. That means inverse exists. So A inverse will be 1 upon det A. Det A is nothing but AD minus BC. Now to find adjoint, it's very simple. What you have to do means, you have to interchange these two numbers, whatever numbers are given, like A will become D and D will become A, and just put minus sign for B and C. That is nothing but your minus B minus C. So similarly, take an example like, so if you want to find the inverse of 1 2 3 4, so what you have to do, you will directly write A inverse is equal to 1 upon det A. Det A is how much? 4 minus 6. 4 minus 6 is how much? Minus 2. And that is nothing but just interchange this 1 and 4. So it become 4, it become 1, and that will be putting minus symbol for these two rest elements. So this is nothing but all about inverse of 2 by 2 matrix, and here we have done inverse of 3 by 3 matrix. Thank you so much. If you like my videos, please if you do share and subscribe. Thank you.